Okay. In the last video, we did the polynomial inequalities. In this video, we'll do some rational inequalities. Understanding the rational inequalities, we need to do a sign analysis, otherwise known as a line analysis. And we're going to consider when the numerator is 0 and when the denominator is 0, right? We're going to want to find these critical values. All right, so I have x plus 5 over x minus 4. My critical values will be at -5, and at -5 my function is 0, and also at +4, and I know at +4 I'm going to have a vertical asymptote. Okay. I'm going to pick a number between -5 and -4, let's say 0. If I substitute in 0, my function is negative. The multiplicity of each critical value is odd, so I must switch signs at both critical values, so from negative to positive, from positive to negative. And if I want to solve the inequality, I want to know when I am less than or equal to 0, and that's going to be from -5 inclusive to 4, but exclusive of the 4. All right, and I'll go ahead and use the parentheses for y'all for this one. So there is the solution to my inequality. Okay, x plus 1 in the denominator. I need to get a common denominator here. So let's go ahead and do that. So I'm going to have x plus 6 minus 2 times x plus 1. All right, and that's going to give me x plus 6 minus 2x minus 2. So that gives me negative x plus 4. So really what I'm looking at is 4 minus x all over x plus 1 has to be less than 0. All right, so let's do a sign analysis. All right, when x is -1, I have a vertical asymptote. When x is 4, I have a 0. Let's pick a number. Doesn't really matter where. I could pick a number out here. Let's say I picked 5. All right, if x was equal to 5, if x was equal to 5 here, then I would have 4 minus x, which is a negative number, and I'd have 5 plus 1, which is positive, so I know I would be negative out there. Or I could say 5 plus 6 is 11, 5 plus 1 is 6, so 11 divided by 6 is a number less than 2, so that's going to be negative. Multiplicity is odd, so change signs. Multiplicity is odd, so change signs. I want to know when my function is negative, so I know that that's going to be when x is less than -1 or x is greater than 4. There's the solution to my inequality. All right, continuing with these inequalities. So I need to factor my numerator here, and let's go ahead and factor. It's going to give me x plus 3, x plus 5. So number line, 3 critical values at -5, at -3, and at -2. All right. At -2, it's a vertical asymptote. A 0 at -3, a 0 at -5. All right. Choose a number somewhere. 0 is an easy number to evaluate. If x is 0, I have a positive number. Multiplicities are odd, so change signs, change signs, change signs. I want to know when I'm positive. So I know I'm going to be positive if I am between -5 and -3, exclusive, or if I am greater than -2, right? Your choice on how you want to use your notation. Just be consistent or make sure that if it asks for an inequality, you provide an inequality. All right. This one over here, if we consider what we have, let's see here, x minus 8, x plus 3 in the denominator. Sign analysis. We have negative 6 for the 0. We've got negative 3 for a vertical asymptote. We've got positive 8 for a vertical asymptote. Choose a number. 0 is usually easy to work with, right? So if x was equal to 0, this would be a negative number. Change signs, odd multiplicity, change signs, odd multiplicity, change signs, odd multiplicity. When am I greater than or equal to 0 would be if x is greater than or equal to 6 or negative 6 but less than negative 3, or if x is greater than 8. And so there's my solutions. Okay, so solving rational inequalities uses sign analysis. Make sure you're able to do it. Polynomials, you can do sign analysis as well. Some people like to draw the graphs. It's your choice. Drawing the graphs with polynomials is not quite as difficult. Drawing the graphs with rational functions tends to be a little bit more difficult, so people tend to not draw the graphs. Okay. Need help with inequalities? Make sure you practice. Use Perplexity AI or other similar thing to get you additional practice problems as needed. Come in and ask questions for clarification. Thank you for your time.